What are the questions? So, how many of you have solved this question? This homework? Only one hand. Okay. So, any doubt? Any student having doubt? No. Okay, we will solve this. So, what is the first question? What is the first bit? Check the dimensional correctness of the equation. What is the equation?
Sir, T equals to 2 pi root over L by G.
Yes. So T equal to 2 pi root over of L by G. So we have to verify that this equation is dimensionally correct or not. Okay. And we have already done how to proceed. We have to see LHS and RHS. So LHS. LHS only T is there. T is the time period. And what is the dimensional formula? M0, L0, T1. Is not it? The dimensional formula is this much. Hmm. Similarly, the right hand side, if those have done, please check it. And those have not done, you just write here. One thing is that why you are not doing, that is the very unfortunate thing. How many of you have done the homework? Very few. Huh? All of you should do, also, try also. See, 2 pi is a constant quantity, so it has no dimensional formula, then root over of L by G. Root over of means power is 1 by 2. So L is L1 and G is what? Who will tell me acceleration due to gravity? What is the dimensional formula?
Sir,
LT minus 2.
Sir,
It
LT
is
minus 2.
okay. It has same dimension formula as what acceleration? Huh? Because it is acceleration due to gravity. Okay. Uh, okay. So L1 T minus 2 and whole to the power half 1 by 2 because of square root. Whole to the power 1 by 2. So let us simplify this. L1 L1 cancel out. So it is L0, then T minus 2 just in the denominator. So when it goes to numerator plus 2 whole to the power 1 by 2. So it becomes L0 T1. Is not it? L0 T1. Understand all of you?
Yes, sir.
So since the dimensional formula in both LHS and RHS are same, the equation is dimensionally correct. Okay, you just mention one line. Since the dimensional formulas, in LHS and RHS of terms of both terms in LHS and RHS are same. You understand this. Since the dimensional formula in LHS and RHS are same, the equation is dimensionally correct. Okay. So the equation is dimensionally correct. Is it clear? Second bit,
Sir, F equals to mv cube by r.
F equal to mv cube by r. Okay. How many of you check it that it is dimensionally correct or dimensionally wrong? How many of you have done this question? Only one student. Two, Pratichi. Three. Yes. You have done. Simeon.
sir, what is the question?
Question is F equal to mv cube by r. Last class, na? Yesterday's question.
Sir, it will be MV square by L, I think.
MV square, na, it is given MV cube.
Sir, 1 minute, sir, I'm checking.
Okay. Uh, Lata Sharma. Your name is Lata Sharma?
Sir, my name is written in the bracket Ashi.
Oh, your mother's name is Lata Sharma, or what?
Yes, sir.
Oh. And you have done what you find? It is dimensionally correct
Sir,
or?
no, sir, it
Yes.
is incorrect.
Okay. How do you know?
Sir, because the dimensions of left hand side and right hand side do not match.
Yes. So LHS, what the dimension? Tell me. Left hand side, what the dimensional formula? Force dimensional
MLT
formula.
minus 2.
Sir,
M1,
MLT minus 2.
M1 L1 T minus 2. And right hand side, what is the dimensional formula?
Sir, M1 L2 T minus
M1
3.
L2 T minus 3.
Okay, let us write mass is M1 and this is velocity. Velocity dimension is L1 T minus 1
Minus 1.
and cube. So it is L3 T minus 3. Directly I am writing. Then radius is L1. So the final answer becomes M1 L2 T minus 3. Okay. So the LHS and RHS are not matching. Since the dimensional formula in LHS RHS are not matching, the equation is dimensionally incorrect. Okay. Just mention that since the oh, sorry, since the dimensional formulas since the dimensional formulas in LHS and RHS are not matching, are not equal, the equation is dimensionally incorrect. So then what will be the correct equation?
F is equal to mv square by r.
Hmm. So this equation to people are familiar. If any other things are also given, you can check. And you can predict also what may be the possible modification in the formula for the equation to be correct. Okay. The equation is dimensionally correct. Okay. Then next question.
Sir, P is equal to A plus B by T plus C by D plus T.
Hmm?
Sir, we have to find the dimensional formulas of A, B, C, and D.
Question number two. Just tell me the equation. X
Sir,
equal
P,
to no, P is equal to
A plus B by T
A plus B by T
plus C by D plus T.
D plus T. Okay. Okay. And we have to find the dimensional formulas of A, B, C, D. Four constants. So how many of
Yes,
you
sir.
have done this? Yes.
And sir, P is momentum and T is time.
P here P stands for momentum and T stands for time. Okay. Uh, how many of you have done this? Only two students have raised their hand. Three. Hmm. Hmm. Boys? No boys have raised your hand. Why? Hmm? Any problem? You
Sir,
people
I
don't
have a
all.
great confusion in this.
Yes, yes. Confusion. Yes, tell me. Share your confusion.
Sir, how to find the dimension of A and D? Sir, D.
See, you just remember this principle of homogeneity. Physical quantities having same dimension can be added or subtracted. So here D is added to T means D must have dimension of T. Finish. Isn't it?
Okay, sir.
Sir, then A and C will have same dimension?
A and C, A and C, no, B and C. D has same dimension that is as T, so T1. Then A has same dimension as P. P is momentum, so it is M1, L1, T
Yes,
minus
sir.
1. And B has dimension of P and T because B by T equal to P. So B equal to P into T. Okay. So dimension of momentum M1, L1, T minus 1. Then it is T1. So it becomes M1, L1 only. So B has dimension of what? M1, L1. And this is equal to C. This is equal to dimension of C. Because C by T also. B by T, C by T also. Is it clear? B and C
Yes,
has
sir.
same dimensional formula, and A
Okay,
has
sir.
dimension of momentum, and D has dimension of time. All these questions can be solved using the concept of what? Principle of.
Homogeneity.
Homogeneity.
So idea clear.
Yes, sir.
So
Yes,
I
sir.
hope all of you understand. Okay. So by this we complete your first application. First application of dimensional analysis to check the correctness of a of an equation in physics or in scientific equation. The second one is very interesting. Means see this means if you know also this method is interesting. It has some limitation also. This method everything in this world has some limitation. This means application of anything is limited. To some extent it is giving the result. Some other cases it may not give the result. So we should know both the things, its drawbacks as well as its success. Huh? Um, okay. So second application is to derive relation among various physical quantities. Okay. So second application. All of you write application to derive. It is visible. Okay. To derive relation among various physical quantities. To derive relation among various physical quantities. Okay. So have you written?
Yes, sir.
Okay. See, I will first teach this by giving an example, so that you understand it. Okay. So all of you have written. Let me turn over my page. Okay. See how we are able to derive a relation among various physical quantities. See, example one. So through examples you understand. We will understand this method. This means see, we will by experiment or by observations or simply sometimes guesswork. But guesswork should not be complete wild guess. It should be some calculated logical guess that a physical quantity depends upon some other physical quantities. Okay. Once that is established, then you are able to derive a relation. And also all relations, all equations you cannot derive by using this method. It has its own limitation. We'll discuss that. Suppose one example I am telling that centripetal force you are just now telling. I have told mv by r, it is coming dimensionally incorrect, and you are told it is mv square by r. Okay, let us check it. Let us derive this relation. That centripetal force is actually is coming mv square by r by dimensional method. Okay, so I'm writing this question. The question is given like that. The centripetal force. All of you write the centripetal force. Hmm. The centripetal force uh, acting centripetal force in bracket I am writing F. The centripetal force acting on a body uh, moving in a circular path. So whenever a body moves in a circular path, then only centripetal force comes into play. Okay. Without that, centripetal force will not be there. The centripetal force acting on a body moving in a circular path of radius r depends on you see, since the body is moving in a circular path of radius r, you can guess obviously the force will depend on what? Mass of the body, speed of the body, and radius of the body. But how it depends, we don't know. It depends on its mass m, velocity v, and radius of the circular path r, and radius r of the circular path. Okay, so in the question it is given that the physical quantity depends upon what? Physical quantities, that is given. Okay, then what we have to do? We have to derive the relation. So question is find a relation for the find a relation for centripetal force by obviously dimensional method, by using dimensional method or simply by dimensional method. See, this method has the obvious limitation or shortcoming is that constant of proportionality value is not known by this experiment, by this analysis. Constant of proportionality you have to find by some experiments, some indirect methods. So in this problem, so that is why in the problem they will take the value of constant of proportionality this much. So in this problem I am giving you take k equal to 1. Okay, k is the constant of proportionality. K is what? Constant of proportionality. So is it clear? Is the question written by everybody?
Yes, sir.
Okay. Then let us proceed. How to derive the relation among this. Since we don't know how centripetal force depends on mass or velocity or radius, so we assume, okay, solution. We assume let force proportional to mass to the power x, force proportional to velocity to the power y, and force proportional to radius to the power z. Okay, we don't know how it depends, where x, y, and z are unknown constants. Are unknown constants. Is it clear? Is it clear up to this?
Yes, sir.
Yes, sir.
Okay. So therefore, if you combine everything, a proportional to m to the power x, b to the power y, r to the power z, this implies f equal to some constant k. K is the constant of proportionality. F equal to some constant k, m to the power x, b to the power y, r to the power z. Okay. So this is your, and k in the question is given take 1. In the question is given take k equal to 1. So we substitute k value. So f equal to k equal to 1. So m to the power x, b to the power y, r to the power z. This is equation 1. After this clear, all of you understand this?
Yes, sir.
Okay. So once this has been done, then what we have to do? We have to write the dimensional formula in both LHS and RHS. I'm writing it also since I'm doing it first time for you people. I'm writing all the steps. So writing the dimensional formula in both sides. Writing the dimensional formulas plus in both sides. In both sides. So what is the dimensional formula of force?
MLT minus 1.
M1 L1 T minus 2. Then mass dimension is m1, power is x. Velocity dimension is L1 t minus 1, power is y. And radius is L1, power is z. Okay, radius is L1, power is z. So this implies it is m1 L1 t minus 2. Then you simplify. See, m power 1 x means m to the power x, is not it? Then L to the power y, then L to the power z is there. So when in case of that exponents a to the power m into a to the power n equal to a to the power m plus n. Similarly here y plus z L to the power, then 2 to the power minus y. Okay, is it clear up to this?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Uh, Once this has been done, now you see in LHS, RHS, you have to equate the powers. Equating the powers. So equating the powers uh, of MLT in both LHS and RHS. Simply I'm writing equating the powers. You understand that. So x is equal to 1. Is it clear? Because left hand side m power is 1, right hand side m power is x. So x equal to 1. Then y plus z is equal to 1. Okay. And minus y is equal to minus 2. This implies y is equal to 2. So that we got x equal to 1, y equal to 2. So therefore, y plus z equal to 1. So from this, z equal to what? 1 minus y, that is 1 minus 2. So z is equal to minus 1. So we got z also minus 1. So is it clear? We have to find the values of unknown variables. So that are x, y, and z. Is it clear? How we have found it? You understand this or not? We
Yes,
first
sir.
we first equate the power so that we get some equations and some direct solutions. Then we solve it and find the values of all the three variables. Now you have to put the values of these three unknown constants in equation 1. Like putting the values of unknown constants, putting the values of x, y, and z in equation 1. So what do you get? F equal to m1 v2 r to the power minus 1. So that is mv square by r. Okay, prove. Are you able to get it? Understand it?
Yes, sir. Yes, sir.
Yes, sir.
All of you understand it? Please check it again. Again see it. If you don't understand, somewhere I will explain again because after this I will give you a question you have to do. You just check it. Where you don't understand, please tell me. Okay, anybody who don't understand, please tell me. All of you understood?
Yes, sir.
Okay.
Yes,
Now,
sir.
uh, uh, okay, if anybody don't understand, please tell me where you don't understand. And if you are, or if you understand, we'll proceed. Tell me, quick. Okay, we'll proceed. See, now I'm giving you one question to all of you to do. You try to solve this. Hmm. So, question number uh, today one, first question. Hmm. Okay. Hmm. Okay. I'm just telling you that kinetic energy, kinetic energy depends on kinetic energy depends on mass of the body. Kinetic energy, suppose you take K, capital K, or ek, kinetic energy at ek. Okay, depends on mass m and velocity v, velocity v of a body. Okay, question is find an expression for kinetic energy by dimensional method. Find an expression, for kinetic energy, hmm, by dimensional method. This is a simple question, so people can do and take k equal to half. In this question, it is given take k equal to half. So is the question visible to all of you?
Yes, sir.
Okay, write the question, solve it, then tell me. Okay. So quick, quick.
Yes, sir, done.
Sir,
Okay.
completed.
Who has done? Name please.
Sir, Pratichi.
Okay, Pratichi.
Sir,
What is your
Ashi.
full? Let's see. What is your full name, Pratichi? Pratichi.
Yes, sir, Pratichi Das.
Pratichi Das. Asi Pratichi. Asi or Asi just? Asi.
Sir, Ashi Sharma.
Asi. Okay. Anybody else? Boys? No boys are doing. Dipankar Das. Are you there? Oh, done. Simeon, we have done.
Yes, sir. Just equating the powers done on sir.
Okay. Hmm.
Sir, myself Rishita I have done.
Oh, Rishita, you have done, Nagi. Okay, good, good. Some students are able to pick up and some are not. Okay. And what you got? What the final formula you got?
Sir, x means m ka power is coming 1 and velocity's power is coming 2.
Coming?
So
So
the
velocity.
final answer is half a mv square.
Okay. Okay. So I am also solving this for you. You just verify. and those have not done or understand and see how it is being done. Hmm. So one class, one application we are able to solve. It's okay, no, don't worry, because it's online class, and if people are new to class two, so don't worry. We will proceed little slowly. Okay. See, according to the question, kinetic energy depends on mass and velocity. So you should write like that: kinetic energy K proportional to m to the power x, and K proportional to v to the power y. It is clear. Ek proportional to m to the power x and ek proportional to v to the power y. Is it clear? You just mentioned that where x and y are unknown constants. Hmm. X and y are unknown constants. So therefore, if you combine both the things, ek proportional to m to the power x, v to the power y. This implies ek equal to some constant k, m to the power x, v to the power y. And according to the question, that constant is what? That constant is half. Hmm. So therefore, it becomes ek equal to half m to the power x, v to the power y, equation 1. Up to this clear? All of you have written like this?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, good. Then you write the dimensional formula both sides. So Ek dimension is m1 kinetic energy m1 L2 T minus 2, and half the numerical constant is node dimension. Mass is m1 power x, velocity is L1 T minus 1 power y. Is it clear? If you simplify this, it is m to the power x, L to the power y, T to the power minus y. Very simple. Then you equate the powers. Equating the powers. Equating the powers. We got x is equal to 1. We got y is equal to 2. Minus y is equal to minus 2. So same thing. Y is equal to 2. Again I am writing minus y is equal to minus 2. So y is equal to 2. So we got the values of x and y. So you put the value, putting the values of x and y, putting the values of x and y in equation 1, we get ek equal to half m power 1 y power 2. So ek equal to half mv square. So you understand? See how powerful the dimensional analysis is. You are able to derive some equations if you know the physical quantity depends on which other physical quantities. Is it clear?
Yes, sir.
So all of you understand the application? How to derive relation among various, okay. How to derive relation among various physical quantity. Okay, anybody having doubt or something? No, all of you understand.
Sir, can you take the copy little bit left?
Little bit left.
Thank you, sir.
Your left, my right. Okay. Mhm. So finish. Now I am giving a homework. All of you write this question, and tomorrow come prepare this. See, tomorrow I think we have double periods. Huh? As we have discussed,
Yes, sir.
I'll teach the first period, second period I will give you some questions to do. Huh? And we'll discuss the question also. So homework. Homework is, suppose you write a new question, but you can able to do it very easy. Right, the orbital speed of a satellite, orbital speed VO, Okay, orbital speed VO of a satellite depends on you can guess if a satellite is moving around a planet in a circular path with some velocity, then on which factor it will depend? Definitely it depend on its velocity and the radius of the circular path and another constant, that is your gravitational constant. Okay, the orbital speed of a satellite depends on gravitational constant, universal gravitational constant. In shortcut, gravitational constant capital G, then mass of the planet, satellite, sorry, mass of the mass of the planet, capital M. See, mass of the satellite will get cancelled out. So that's why it does not depend on mass of the satellite, rather it depends on mass of the planet. Gravitational constant G, mass of the planet, and uh, radius of the circular path, and radius capital R of the circular path. The circular path. Okay. Question is, find an expression for orbital speed of the satellite. Find an expression for orbital speed of the satellite. Okay, orbital speed of the satellite, and take k equal to 1. Take k equal to 1. So are you able to write the question?
Yes, sir.
Yes, sir.
Okay. So today this much, and we have completed the second application.